China's advanced J-10C fighter jets, loaded with precision strike weapons, just entered a simulated battlefield against Israel's world-famous Iron Dome air defense system, and the results shocked military analysts worldwide. In this war game scenario, the skies lit up with high-speed dogfights, missile interceptions, and electronic warfare moves that could completely change how future wars are fought. The simulation wasn't just about firepower, it was about testing two of the most powerful military technologies head-to-head, and the outcome? It left experts stunned, raising urgent questions about whether Iron Dome could really hold its ground against one of China's most advanced fighter aircraft. Hello everyone, welcome back to my channel. Please subscribe and like my videos. Imagine this, a squadron of J-10Cs roaring over the horizon at supersonic speed, their radar systems locked on targets, while Israel's Iron Dome scrambles to calculate incoming threats in real time. The J-10C, China's pride in fifth-generation fighter jets, is armed with PL-15 long-range air-to-air missiles and precision strike weapons. On the other side, Iron Dome, designed primarily to intercept rockets, artillery, and short-range missiles, finds itself facing a completely different kind of challenge: high-speed aerial assaults from manned fighter jets. This wasn't the battlefield Iron Dome was originally built for, but in the simulation, it had to adapt fast. Military strategists have long debated what would happen if advanced air defense systems like Iron Dome had to face not just crude rockets, but highly sophisticated fighter jets equipped with electronic countermeasures, stealth features, and smart weapons. And the J-10C, with its thrust, vectoring engine, modern ESA radar, and compatibility with China's most advanced missiles, provided the perfect test case. The simulation began with J-10Cs flying in coordinated formation, using electronic jamming pods to confuse radar systems. Their goal wasn't just to launch missiles, but to overwhelm Iron Dome's sensors, which rely on quickly detecting and calculating the trajectory of incoming projectiles. Once the electronic warfare began, analysts noted that Iron Dome's radar struggled under heavy jamming. Some missiles slipped through undetected, but Israel's system responded with adaptive countermeasures, recalibrating its interceptors to lock onto the most dangerous threats. What shocked observers was how fast this electronic chess game escalated. Within seconds, J-10Cs fired multiple salvos of air-to-surface missiles designed to mimic incoming rocket barrages, forcing Iron Dome to spend valuable interceptor missiles. But while Iron Dome managed to neutralize many of them, its ammunition supply became a critical weakness. Unlike the near-endless supply of rockets that insurgents often fire, the J-10C could carry fewer but more precise weapons, each with a higher chance of penetrating defenses. The cost imbalance also became obvious. Each interceptor missile fired by Iron Dome costs tens of thousands of dollars, while the attacking J-10Cs could unleash waves of relatively cheaper guided weapons. In a prolonged conflict scenario, this economic strain could put Iron Dome at a disadvantage, especially if facing coordinated fighter jet strikes. But Iron Dome wasn't defenseless. The simulation revealed its advanced algorithms adapting to distinguish decoys from real threats. Its Tamir interceptors successfully took down several precision missiles before they could hit critical targets. Experts highlighted that while Iron Dome was never intended to face fighter jets directly, its flexibility and upgrades made it surprisingly resilient. Still, when the J-10Cs combined electronic warfare, precision-guided bombs, and saturation tactics, cracks in the defense system began to show. One striking moment in the simulation occurred when a J-10C launched a hypersonic-capable missile designed to travel at extreme speeds and maneuver unpredictably. Iron Dome, optimized for slower and more predictable rockets, struggled to track it. In real battle conditions, such a missile could devastate critical infrastructure before an interceptor could respond. This raised the chilling possibility that Iron Dome's shield might not be enough in a future where advanced fighter jets carry next-generation hypersonic weapons. At the same time, the J-10Cs faced their own vulnerabilities. Fighter jets are far more expensive and limited in number compared to simple rockets. If Iron Dome managed to intercept enough missiles, the J-10CS risked running low on weapons and fuel. Additionally, operating in contested airspace against integrated air defenses could put these jets at risk. Some analysts suggested that pairing Iron Dome with longer-range systems like David's Sling or Arrow could create a layered defense capable of stopping even advanced jets like the J-10C. What made this simulation truly shocking wasn't just the technical side, it was the geopolitical implication. China's J-10CS represent Beijing's growing military reach, while Iron Dome symbolizes Western and Israeli defensive innovation. The clash of these two systems, even in a simulation, hinted at what could happen if Chinese technology ever found itself facing Western defense systems in proxy conflicts around the world. Would Iron Dome still dominate? Or would the new generation of Chinese fighters expose its limits? The psychological effect of this scenario was also huge. Iron Dome has built a reputation as nearly invincible, a shield that protects Israel from countless rocket barrages. Seeing it challenged by advanced aircraft in a war, game shocked many observers, forcing a reconsideration of how much trust should be placed in any single defensive system. At the same time, the J-10C's performance boosted China's image as a nation capable of producing world-class military hardware that could potentially neutralize some of the West's most celebrated defenses. Another key lesson from the simulation was adaptability. Wars of the future won't just be about raw firepower, but about how fast systems can learn, adapt, and respond to evolving threats. Iron Dome, though designed for rockets, managed to hold its own against advanced jets, proving the value of flexible design. Meanwhile, the J-10C showcased how fighter jets can use electronic warfare and saturation tactics to push even the best defenses to their limits. Experts now believe that the next stage of this rivalry will focus on artificial intelligence. Imagine Iron Dome using egg-driven interceptors that can learn the flight patterns of hypersonic missiles in real time, or J-10CS deploying AI-enabled swarms of drones alongside fighter jets to overwhelm defenses. This simulation may have been shocking, but it was also a glimpse into a future battlefield dominated by speed, intelligence, and adaptability. The world is now watching closely. If Iron Dome can evolve to meet threats like the J-10C, it will remain a cornerstone of defensive technology. But if fighter jets like the J-10C continue advancing with hypersonics, stealth upgrades, and drone coordination, even legendary defense systems may need complete overhauls to stay relevant. So, what does this all mean? The shocking clash between China's J-10C and Israel's Iron Dome was a wake-up call for militaries worldwide. Defense systems that once seemed invincible may not be enough in the next era of warfare. At the same time, offensive technologies are evolving faster than ever. The race is on, and the outcome could decide the balance of power in future conflicts. And as analysts concluded, one thing became crystal clear: the future battlefield will no longer be about one system versus another. It will be about entire ecosystems of technology working together. Whether it's Iron Dome, the J-10C, or the systems that follow, adaptability will determine survival. The simulation shocked the world, but it also gave us a preview of tomorrow's wars.